Okay, well, um, thanks for thanks for being here. This is actually the first tour that I've given of our chemistry island, chemistry world. Um, so this should be fun for hopefully fun for everybody. I'm looking forward to it. Um, what we this was the island that we used for the Texas A&M general chemistry uh, lab project that I told you about, I guess, a couple of months ago. Um, my collaborator, Dr. Wendy Keeney Kennicott, had been involved in Second Life for um, at least, well, she had been involved in using Second Life for education um, for several years before this, and so um, she wanted to collaborate on the project I had in mind, and that was great because she knew a lot more about Second Life than I did. In fact, she had already established a, a a Second Life island that's part of the Texas A&M 12th Man Island, and 12th Man is a I don't know. I always associate it with their Texas A&M football. But it's kind of a common phrase used at Texas A&M. So they have 12th Man Island in Second Life, and Wendy has some chemistry uh, exhibits and information on that island, which is right across the bridge, right behind you. Um, and so you're welcome to go over there and look around. There's also, I think, other faculty have established. They have some a presence there. They have classrooms and presentations and um, displays and other things going on. I think among universities I found, Texas A&M has probably one of the strongest presence in Second Life. Now, let's see if we look at my bearings here. Um, Actually, if we go, we don't have to go through it since you'll see a lot of this stuff in the actual lab. But behind us, what I'm looking at over the bridge, there's a big black backdrop, and then what is actually two very large graduated cylinders. I'm sorry, excuse me, ring stands with burettes attached. When the students first came into Second Life, um, they had to be trained to do a couple of things, like change their the perspective of what they're seeing. So you know, adjusting their camera. They had to they and how to well, they had to pick up a pair of goggles. So there were some other very specific tasks that they were going to need to use, or skills they were going to need to use during the experiments. And so we had a training area that was set up, like I say, just across the bridge there. The training was mandatory because they otherwise we found they just would muddle around and get frustrated and take a lot of time that they should have been spending just doing their lab experiments. So this is where they would begin, and what they see and what you see is a pretty well landscaped environment. The building that's labeled Heldenfels 2. Heldenfels is the lab building that is actually on the Texas A&M campus where they teach their general chemistry labs. This is the second virtual rendition of that. It looks nothing like the real building. Wendy specifically asked the designers to make something that looked attractive. I guess the one on Texas A&M, which I've never visited, but the one on Texas A&M is I guess an example of brutalist architecture. It's very square and functional, and could probably withstand, you know, a frontal assault by military or something. So this is a much more attractive building. And then if you go, you can go around the building. There's like hills behind it. There's actually a couple of displays. I will mention Wendy has set up a display for her watercolors. She's a really good artist, as well as a chemist and educator. So actually, if you go behind, you can see some of her picture virtual versions of her watercolors, which is pretty neat. But we really wanted a nice, attractive area for students to to be in, even though they spent about probably 2 minutes in the landscape portion. They spend almost all their time actually in the chemistry lab itself, which is where we can go now. There's two ways to get there. If you have the HUD, you can click on the little home key, and it will take you into the chemistry lab room, or at least you might say the starting point for the lab. So you can do that, or you can do it the old-fashioned way and just sort of walk there. It's through the doors and to the right. If you go into the building, you'll see that there's a lot more to the building than just the chemistry lab itself. Again, we wanted to make this sort of an attractive place for students to congregate. I don't know that they actually did congregate very much. They were here for a class after all. But it does look nice, and if you can wander through it, and there's some rooms, and there's a coffee bar and some other things. So if you want to meet me next in the chemistry lab, again, by clicking on the home button on the HUD, or you can just follow me and we'll go to go into the lab right now. So it's just through these doors. And to the right. But like a real chemistry lab, don't touch anything just yet. I don't want you to disappear and be teleported away before you're supposed to be. Okay. I assume everybody is here. So the outside of the building, or the rest of the building, is a new version of the actual chemistry building at Texas A&M. But this room was made specifically to be as an authentic replica of the actual chemistry lab. We really wanted students to feel sort of comfortable, like they had been here before. They were only doing 2 lab experiments in Second Life, but we didn't want them to have to feel to become acclimated to a new environment. We wanted to make it as similar as possible. So everything in this room is a copy of what their regular chemistry lab looks like. Now, I don't know if you want to look on the far side, there's an opening into another classroom. If y'all want to go in there and look, you can, but it's simply a classroom where the students would get their pre-lab briefing. So there's some slides, some slide screens set up. Actually, there's still some presentations on display there, but it's nothing particularly special. Now, the students would come in, and you can see these what are water molecules, the little rotating red and white 3 little spheres. Pairs of students a student and that student's lab partner would each click on a sphere, and they would be teleported to a lab platform. We have enough lab platforms for an entire class, but once you go to another platform, I go to, then you're going to end up outside of my chat range, and so I won't be able to communicate with you. So, does anybody not have the HUD? Because I think that's going to be an easier way for us to get around. Okay, so we're seeing no objections to that. Let's all go to the same lab platform. Now, the HUD that you were given was really designed just for the instructors of the lab course. The students did not have this. There's two sets of buttons. First we'll use the ones in the blue and white portion. There are 12 lab platforms, or 12 lab stations, which is good because that means you can have 24 students doing the experiments, which is about the right size of a course. So why don't everybody click on Lab Station 1 in the blue and white portion, and you'll be taken up there. You'll go to the same place as if you clicked on the rotating water molecule labeled Station 1. But I think this will just be easier. So I will see everybody up there. Looks like everybody is disappearing. It's good. And here we are. All right, so this is where the magic happens. Now, if we look out past the edge of the platform, we're actually way up in the sky. There are a couple of things that you can see here. Even before we get to the experiment, you can see there's a slideshow. This is showing the same pre-lab briefing that the students got earlier in the other adjacent classroom. So if the students need to just check something that they forgot about, they can click through the presentation slides. There is a rotating water molecule that if you click on that, you return to the room we were just in. There's a sphere. Okay, so next to the water molecule is this little thing with the green button. If I click on that, watch what happens to your HUD. The lab station number 1 spot on the HUD just turned red. Now, if you were an instructor and you were on some other lab platform, you would now know immediately that, oh, students in station 1 have a question. But maybe you've got a couple of lab instructors who are helping out. One of them goes there and clicks on it, and the red alert goes away. And so the other lab instructor can then realize, oh, somebody else has helped those students. Maybe the students had a question, but then they figured it out themselves, so they canceled the alert. So it's a very nice way for the students to communicate. In some ways, kind of discreetly. Instead of raising their hand and saying, "Hey, instructor, I need your help," they could just click on a button, and only the instructor would know that student or that those lab partners needed help. Next to that is a sphere. If you click on that, you get a note card called Laboratory Links, and you're welcome to do that. It has links to PDF files which contain the actual lab experiments. In our study, the students used the same lab manual as students in the real lab. And so this was just another way of making that information available to them. And let's see, and then there's, oh, and then the other slideshow is for the second lab experiment. On this platform, there are in fact 2 lab experiments available. We, since since all the students performed one experiment at a time, they could just go to the first one they went to is over here on the right, to the right facing the lab backdrop. And then the next week they did the lab experiment on the left. So if you're not familiar with what a chemistry lab might look like, you're the the backdrop, the ground we're standing on is sort of reminiscent of a chemistry lab bench. You'll notice that all the equipment is above a larger scale. That was just to make it easier for students to see what they were doing. You can, in fact, I believe you can fall into the sink. I'm pretty sure. I haven't tried that yet, but I'm pretty sure you can. I know students could walk into the lab balance and do kind of goofy things like that. But, if you zoom in to the point where you don't see the back of your head, then really all you see is the lab equipment, and it kind of looks like normal size. So it wasn't as, it looks kind of goofy, but you get used to it once you start doing the experiment itself. Before we do, well, I'm not going to go through and do both the experiments for you. You can play around with it if you want yourself. But one other feature of the HUD that I'll show you is, so there's 12 lab stations, and we're on lab station number 1. And we got here using the blue and white portion of the HUD. Above that are 12 buttons labeled 1 through 12. If you click on button number 1 at the top of the HUD, the gray button, go ahead and do that and see where you end up. So just to let you know, they are on the other side of that black background. It's a one-way wall, and so this was used so that we could observe what the students were doing without them feeling like they were being watched.
I'm sorry, I was answering a question in another window. We click.
You fell to the ground? I didn't know. Oh, that is I've never heard of that happening before. That's okay. So, well, let's see. So you get transported to the back side of the black wall that I'm facing. Huh.
I gave mine permission, but I didn't go anywhere.
So did anybody get? Oh, I'm sorry. Excuse me. Did anybody get transported to the backside of this where you could actually see people? I mean, see the lab bench from behind. Oh. Well, I'm not sure why that happened. Um, oh, we may have had a we may have had a permissions list that only allowed certain people back there, and obviously none of you are all on there. But that's yeah. I think that that must be it. Ah, okay. Well, sorry about that. Well, it is a nice little feature that the designers made for us, um, that would allow us to kind of stand back there and observe the students. Um, okay, but from the student's standpoint, this that wasn't really something. Yeah, well, in fact, we didn't flying. It's interesting you mentioned that um, we didn't allow flying because it's really not well. We really just didn't want students to spend all their time goofing off. And so um, I think now we've opened up flying because we have visitors and you know it is easier for people to get around. Um, but yeah, we had turned off flying for the actual work. Um, if y'all want to come over here, I can show you some of how we actually how students would actually do the experiment. So this is, I'm not going to go into detail about the everything about this experiment. If you want to really learn about it, download the PDF, and you can read about it. We we designed this experiment so that students go through perform a series of steps where they assemble a little apparatus, and they end up figuring out a kind of an essential property, what we call the molar mass, um, of a particular compound. Um, and this is kind of just a very um, a very important. It's an important concept in freshman chemistry, and so this is, but it's sort of a theoretical idea, and this is a way for them to actually go about collecting data where they can calculate this value associated with the chemical. The chemical they're talking about is butane. Um, and both of these experiments are sort of the topics were chosen because it's Texas, and Texas is big on one thing, petroleum. Um, Butane is a petroleum is a compound found in petroleum, and so they find the molecular mass of a petroleum compound. The other experiment on the far side is actually measuring the salinity of an estuary. Um, that it's another. I mean, on the Gulf Coast of Texas, they have estuaries, and so that's another kind of Texas themed experiment they had. Okay, so here you can go ahead and people can click on different items, and what you'll see is in many cases you'll see a menu pop up, and it will allow you to, and it'll give you choices of what to do with an item. Um, so you should be able to click on anything and move stuff around. Okay. So the when you when you try and do certain things, you might get a warning saying you must first, like for instance, open the door to the scale. So this was an issue that Wendy and I and the designers thought a lot about, and that is what level of detail do we really want? Because if somebody were to say, "Hey, take the lighter and put it on the scale," the student could do that, and then they would know you pick up the lighter, you open the door to the scale, and you place the lighter on the scale. In Second Life, we wanted them to really think about what they were doing. We didn't want the virtual lab to do a lot of the work for them. And so I think some of the steps get a little tedious. Like if you want to put the lighter on the scale, first you have to open the door to the scale. Well, of course you have to open the door to the scale. Everybody knows that. Um, but we make the students do that explicit step. Um, now, but there's in uh, some of these steps actually have a I guess an important aspect to them as far as good laboratory procedure. For instance, if you were to tell the student weigh find the mass of the lighter, which is a first step in the experiment, they would know to put it on the scale, and of course they would know how to open the do that. But they often forget to close the door. And so when they write down their um, they when they try to write down the mass that's displayed on the scale screen, they'll see that it's fluctuating a little bit. Well, it fluctuates until you close the door, and that's what really happens in a real lab. Um, the scale is sensitive to 1/10 of a milligram, which is not very much mass, and so air currents actually affect. It causes a fluctuation in what the scale is measuring. So good laboratory practice would require the students to shut the door, and then the scale reaches a constant mass, and that's what they record. So, some of we may have erred too far in some cases requiring the students to do every little thing, but in other cases we really had a reason for expecting them to do that. Um, how did they move? Okay, so some objects move automatically if you click on it and there's only one. Um, it, if there's only one task for the object to do, you can click on it and it will do whatever it's supposed to do. If there's multiple things you can do with the object, multiple places where that object could be positioned, then the students they'll get a menu and they choose which action to take. Um, yeah, that's right. Leaning on the balance table does affect things. Um, so now the students did comment that because the menus were effectively kind of like a multiple choice test, um, they the students commented that this really did make the experiments easier in Second Life than they would be in the real lab, and that was a deficiency of our design, but it was really unavoidable. Just couldn't The designers didn't know how to you know allow students to like drag and drop objects and put, with the mouse cursor or something like that to pick up an object and move it. Um, so it was just sort of what we had to deal with. In some cases, um, in some cases we did include a lot of options, most of which made no sense or were incorrect. So the students, in some cases, had to choose from a lot of options to do the correct step in the procedure. But in some cases, the choices were pretty obvious. Um, now, let's see. So there were a couple of things here. So we can, this object here is a thermometer, and if you were to click on this thermometer, there's only one choice. Well, what do you do with the thermometer? You check the temperature. So that's actually not that big of a deal. And So I'm trying to read all the warnings you guys are you guys are getting. Yeah, so you got to fill the tub before you can empty it. They need to know the pressure. The pressure is displayed on the back wall, so that's 751 torr, which is about regular pressure. Yeah. Okay. So Shaoza said limited options are not a bad thing. Yeah, I mean in general that's true. Although we we actually had the students perform this. Oh, Mike Shaw. Okay. um, I, we actually had students perform this experiment, or at least the first step of this experiment, on their own as part of a lab practicum. They performed the real lab version of this, and we found that the steps that the students performed in detail within Second Life um, help in the lab practicum. The students performed those steps better. They were more likely to remember how to do them. There are some steps in this process. We didn't think about it at the time, but there's one step in this experiment where the the virtual lab sort of does skip over some steps, or it does the work for them, and it wasn't something we really thought about, but it turned out to be the case. That particular step did not. They did not perform that step very well in the lab practicum. So we really saw a strong correlation between the detail of the steps the students had to complete in the virtual lab and how that reinforced their what they were supposed to be learning. Um, so I think now if we were doing a pre-lab exercise, yeah, we probably would allow them to skip over a lot of the little mundane aspects of this. But this was a complete substitute, so we always wanted them to, or we really wanted them to. Um, I'm sorry, we really wanted them to learn as many of the same steps as they would if they did this in a real lab. So now we can, okay, so you can, if you want to play around with this again, well, actually, you know what, let me go through and show you what the students had to do, because this is kind of a clever little thing together. First, you fill the tub with water. And let's see, then we're going to need to get our lighter. Let's see, we need to remove the lighter. Okay, so the students would have recorded the mass of their lighter, and they would have had to do that themselves. The virtual lab didn't record anything for them. Although in the background, there's calculations. The lab did run a calculation. It knows what that mass of the lighter was. If the students write down the wrong number, that's going to show up as an error in the results. Okay, so we're going to take the tub on the platform. Let's see, we to take our 50 milliliter graduated cylinder, put that above graduated cylinder. Want to fill it with water. And let's see, then we raise it to the surface. Okay. We then take our tubing here and we connect the two. And let's see, then place the tubing in the tub. Okay, so there was a little visual glitch here. The tubing, let's see. Oh wait, no, I'm sorry. There isn't a glitch. They have to. Wait, hold on a second. I'm sorry. Uh, Insert tubing into the graduated. Okay, so the idea here is that you have butane gas in the lighter. You have tubing running from the lighter to a graduated cylinder that is filled with water, but upside down, so that now when we click on the lighter, we can start the release of butane. And after a minute or two, you'll see, and you can zoom in and see this in more detail, but the lighter is, once it's opened, the butane gas is released. It goes through the tube and it collects in the top of the graduated cylinder. And we do that so that we can measure the volume of butane gas that is collected. And you can already see the volume of course, as the gas collects in the graduated cylinder, it displaces water, and so the water is pushed out, and you can collect a volume of gas. So they can measure a volume of butane gas. They measure the mass of the lighter afterwards, and there's a change in the mass because some of the butane gas has leaked out of it. And from the difference in mass and the volume of gas they collect, they can figure out, again, the molar mass of butane. So that they have to do several trials and so forth. So that's fundamentally what the students have to do, and that's what they had to do for the lab practicum. Now, let's say at some point you and I were doing this experiment and we realized, oh, you know what? We forgot to measure the initial mass of the lighter. That is a critical step. We can't get the answer to our experiment without that information. We're going to have to start over. Okay, so in a real lab, you would disassemble everything and you'd have to clean some stuff up and it'd be a big hassle. Here, we have a reset button. And when you click that reset button, the red button right next to the scale, I'm going to click that. And it gives me a pop-up menu that says, are you sure you want to reset? And I said, yes, and poof. Yeah. Yeah, and then everything goes back to where it started. So it was just a time saver. And, while we wanted the students to have an authentic lab experience in Second Life, we also realized, they have limited time. And how do you want students to spend their time in lab? Do you want them cleaning glassware? Maybe. But gosh, I don't know. I think there's better things for them to be doing, like the experiment. I'd rather them have time to try the experiment again to get a better answer, get better data, than to spend their time washing out glassware. But that's a judgment call, and I could see how people might disagree with that. But that's something that the one thing I really appreciated after doing this project is really thinking about all the reasons why you design a lab experiment a particular way. Some things you don't have any control over, like that it's got to be 3 hours long. That you have no control over that. And in the real world, you don't have control over allowing whether students have to clean up after themselves. Well, of course they have to, because no one else will. Yeah, or break stuff. Yes. So if we had had more time, that was the next thing I wanted the designers to do, is to include some kind of a random occurrence of something breaks, and the students have to maybe deal with that, because things break. You drop glassware. It's not a big deal, but it does provide something a little more authentic. But again, is that something you want the students to focus on during this lab time? So there's a lot of choices you have, more choices than I thought about. more choices than I anticipated. Um, you know, when you have the power to design the lab environment from scratch, there's a lot more things to consider. Um, and so you can make it as super authentic with all the hassles of a normal lab, or you can have a little bit of convenience thrown in. Um, so now if you go to the other lab station and you play around with that, that's actually a more complicated lab experiment, both in the real world and the virtual world. Um, there's a lot. It's a little more tedious. I'll just give you a little bit of warning. Um, there's it's a lab experiment that focuses on very careful measurements, and it's not as I guess it's just more complicated. But and that really allowed us to, and in that experiment we really did incorporate. They need 10 milliliters of water, but they're dispensed 10.5 milliliters. Well, now they have to remove zero point 0.5 milliliters. Okay, they do that, but they accidentally remove 0.7 milliliters. Oh, now they have to add 0.2 milliliters. This is like a normal thing in the chemistry lab that you just put up with. And that was something we thought would be kind of a good learning experience for the students. Um, so that we incorporated that into the lab as well. So they have to dispense a lot of liquids in that other lab experiment to do their titration, but it's a very realistic process they have to go through. They record notes just in the a lab worksheet that's part of their lab manual. So we could have had a virtual lab notebook associated with this, but yeah, I don't know. I always thought those were a little clunky, and for the students really needed to write down a relatively small amount of data. So a sheet of paper with a pen worked very well. Yeah. Now the nice thing though would have been, by having them record data into a notebook, then that could have been stored, and the instructors could have looked at that data on their own instead of you know collecting sheets of paper. But yeah, you're right. It probably would be a big endeavor. Um, okay, so that looks like 45 minutes. So um, I think I've tried to give you sort of a an idea of what the students' experience was, as well as the instructor's experience, and what we were able to do. And I think you were able to see everything, with the exception of not being able to behind the one-way wall. So does anybody? I mean, y'all been asking questions, but does anybody have other questions they wanna ask? I'll be happy to answer them and hang around. But I think hopefully you picked up on how to do everything. So you're welcome to go to other lab platforms and play around with stuff, fall in the sink, mix up chemicals. I don't think you can't hurt anything, and there's always a reset button. Future plans. Well, I would very much like to take, not necessarily these. Well, I'd like to do this in a virtual reality setting, um, with more emphasis on students actually handling the chemicals in some way with VR controllers or something like that. Um, Getting rid of all those menus, um, for instance, would be a big improvement, making this a more authentic lab experience. Um, there's a couple of commercial. I was actually just looking at them this morning. There's a couple of commercial publishers that are creating VR labs, and they're pretty neat. Um, but I think I think we could do better. Um, so that's what I'm really looking at now is doing stuff in virtual reality. I appreciate everybody attending. This has been a lot of fun. And like I say, you're welcome to poke around. You can go to other lab platforms just by using the HUD. Um, and like I say, just see if you have any questions or wonder how we did anything. My my only I have to apologize in advance. I don't know anything about the actual programming. But if there's something here that you like or want to learn more how it was done, I can give you the names. Well, Random Cole um, is the guy who did most of the design of the lab experiments themselves. Um, I'm typing his name in the chat right now. Um, and I know he's still active in Second Life and other types of things. Um, no, he lives in Oklahoma actually, near I'm trying to, I've never actually met him, um, which was very strange to like send somebody a check for a fair amount of money that I've never met. But I got over that. He's just a designer in Second Life. He's worked on a lot of other projects, but Wendy knew him, and so we hired him for this work. Yeah, I know. As although it's something I have to get used to, or I am getting used to. But in real life, I'm not actually real active on social media and sharing and things like that. Yeah, you know what? That was so many funny things happened during this project. One of them was just trying to explain to people at Florida Tech, explain to administrators what we were actually doing. Like, what is Second Life? It's like, is it a software? Is it a, is it a publishing company? I gave them just enough information that they, you know, didn't ask too many other questions. Um, and it was the research was funded, so that's really all they really cared about. All right. Well, let's see. I'm trying to see if there are other. Um, guess if there's no other questions, then like I say, feel free to look around and look around over at on the 12th Man Island adjacent to this. Um, there's actually some neat stuff. There's an agricultural setup. There's some people doing education. They've got some presentations over there. And then there's Wendy's stuff that's got a bunch of cute things for chemistry. So, um, yeah, does Wendy? Yeah. Actually, she's given far more. She's given a lot more tours of our project than I have. I know last. I forget. when the last time I saw her in the world, but she does virtual world conferences, presentations, and stuff. Um, so yeah, well, and she is retired, and so um, yeah, that bandwidth may be an issue. Okay, well, and if any other questions come up or you want to take another look or talk to me about it, feel free to contact me and be happy to chat some more. Okay, take care. Bye, everybody.